So, welcome to the next developer meeting today. We have a lot of topics today, and I first want to inform you about some internals, which is we set up a Sky360 merchandise page on Selfie, and we even embedded those products in our website. So if you go to sky360.org and check out the menu, then you will find that there's a merchandise part now. Yeah, we have there just the normal merchandise subjects like t-shirts, mugs, caps, you know. The idea is not to make money with this, and this is important for me to say, because we only have on top costs of $1 to $3, and this is only to cover expenses for transactions. Okay, so actually we do not earn money with Selfie. That's what I want to say. With the merchandise, we do not earn money with merchandise. It's just there to give us all a kind of an identification look. If we all wear the same hats or so, kind of. You know, the ideas of merchandise.
Corporate identity and promotion.
Exactly. And maybe it's a nice gift for someone. The GUI contest hit, I think, round about 50 people went on the website to check out the content about the GUI contest. And I want to encourage all developers at this point to take this link and promote it within your networks, so we get more people interested in participating in the contest. The next part is we set up a documentation folder on the drive, and you all got access to it. The idea is that Jannik took over the part of documenting what we develop. So the result shall be a documentation where not only the what, who, why, when, and so forth, but also the theory behind and all the steps of development from software and hardware side are documented. It shall only resemble the latest status of development. So I urge every one of you, every developer, to put in your whatever, at what stage or ever you produce, I'd say PDFs, Excel files, graphs, code, whatever have you, and drop it there in the drive. And maybe also inform Jannik that you did so that he doesn't have to check every 5 minutes if there's something new. So please inform him that you dropped something, and he will find the content and put it in place where he already knows where to put it. The structure is already set, so Jannik should. I think, Jannik, you've got almost all information now that is needed, so whenever things drop in, you know where to put it, right?
Somewhat. So I looked through the folders, and I've seen that in most folders there are only pictures. So for the documentation, I mean, I don't know in some cases like how the details of the enclosure work or other things that you are working on. So I would need some text.
Mm-hmm.
And in the text, I would like that you refer to the figures that you like to refer to, and then when I have that, I can copy it into our documentation, because I don't know all the details that you are working on, so
Right.
I would need a little bit more help with this.
Yeah, absolutely.
Actually.
Absolutely.
Yeah.
It was not meant to be that way. So I just dropped what I had and what we already had on the drive. So that's just yeah, the PDFs and a lot of images, as you said. And I didn't put any text there yet. I know that it's not your task to create this text, of course. It's I didn't come up to the point to have it done yet. So, but I'm aware of it, and I will certainly for any part create some text so that you also have the glue in between the images, let's say.
Right. Yeah. So as soon as anyone has a text for me, he can notify me, and then I do the rest, basically.
Perfect.
So do you need a synopsis statement? And I'm kind of curious how that's going to be maintained over time, because I mean, I know as we're thinking about the design of the climate control system, it's all over the place. So it's hard to keep up with, even for me. So I don't envy your task. So I'm kind of wondering how to structure that text for you to make this more manageable.
Yeah, I think whatever kind of documentation you have for your topic that you are working on, you can send to me, and I try to figure out where, in which subsection or subsection to put it, because we have a structure, and I will upload the document in the ClickUp that we have, and then you can check out basically if it's in the right spot, and if it's not, you can send me a notification and tell me where it needs to be, basically, I would say.
Okay.
Yeah, so a synopsis is kind of a summary. Is that correct?
Yes. So you're doing more archival stuff as opposed to like doing. I'm sorry, I'm just trying to get an idea of exactly what we're laying out here. You're doing more of an archive versus, say, a prototype, like the documentation that we would have for.
I would say it's a documentation how things work. So the goal was that we put everything in there so that we can replicate what we have done so far, or others could do that, basically.
Yeah.
Okay.
Without needing us to help them.
It's basically a documentation about how we develop things, and not only what we develop, or how the things in the end will work up. It's about documenting the whole development process.
Yeah. So it's thought of as a knowledge base where you can go to if you have any questions regarding other modules that you are not so you don't know much about, but you need to get some stuff out. You can go there and look it up, basically.
Okay, so I'm just going through. Go ahead.
Jannik, I have a question. For example, let's say a software side has, like files, software files, whatever. What kind of files you prefer? For example, screenshot or like a bitmap image or whatever image of what we're doing, not original files, right? You know what I'm saying?
Yeah, exactly. So if you have, if you want to point to any kind of original files, just put it on GitHub, I would say, and from the documentation we can link to GitHub.
More specific is, for example, schematic. Schematic can be only you can open it up in a certain software. But if I send you screenshot in a JPG or BMP or PNG, whatever, so you can share. But I cannot send you original stuff because people need original software in order to open an original file.
Right.
Exactly. In that case, just send me the screenshot. Yeah, exactly.
Yeah. For example, what Brad is doing, 3D printing, whatever, he cannot send you original file. Not many people have, right software to open it up and stuff like that.
Right, but he can put it on a repository and say, okay, that's where it's stored, so that anyone could print it himself if he wanted to.
Oh, okay.
Shall we
folders here, and the GUI team clearly has their act together. So they have like the design doc. That I think that's probably what you're looking for, right?
Yeah, that's the closest version that I'm looking for. Basically, the only thing.
Okay.
I mean, I can basically copy and paste it, but what I noticed is that there are also questions in that document. So questions how we might want to do things, I guess. And in the documentation that I want to compile, basically, I think it's best if we just document that's the status quo, that's how we did things. That's how it works.
Mhm.
But I would leave out any kind of questions that is more like a discussion thing,
Mm.
which we haven't solved yet, basically.
Yeah.
So
Good point. Shall we agree on file formats? Let's say for schematics for the things we wrote out with Fusion 360. Let's say JPEG or PNG.
Yeah, we can export from Fusion 360, like export like a screenshot or export to whatever.
Yeah.
You know, so
Normally, we agreed on writing the documentation with LaTeX. So basically, PNG would be a good solution for it because it has high quality, no quality compression, and low file size.
Yeah, PNG would be nice to have.
Okay.
Yeah.
So, any resistance to that?
no.
Zero. One question, Jannik. You mentioned that you put the documentation, let's say always the final state that you create on ClickUp. My question is, Christian, is this the right place to be? Shouldn't we put it, because for now it's a document for developers only, and not every one of the developers has access to GitHub yet. It's more meant for the team leaders. So why not put the documentation in the Google Drive where we already collected the material for the documentation?
Yeah, since the developers have access to Google Drive much more than ClickUp,
Right.
I think it's the right choice to make, and provide it on ClickUp, not on ClickUp,
Drive.
on Google Drive.
Yeah, right.
Yeah.
Oh, okay.
Maybe on GitHub too. I don't know. I do not know. I don't think that the ones that get the software need the actual documentation file, because it is the documentation about how development goes.
Yeah, it's a kind of milestone documentation. So any step,
Yes.
any in between result is a final version. It's a current version,
Yeah.
which goes into. Yeah.
So
let's keep it on
I
Drive.
would say
for now.
I would say Google Drive is the right place to put it. ClickUps is for the heads of the development teams.
Okay, so I just uploaded the latest version.
Yeah.
So it's called Sky 360 Developer Manual PDF.
Perfect. And it's now on Drive, right?
It's now on the Google Drive,
Perfect.
and there's not much in it yet. So that's
Everything starts
more
by
things
zero.
to come. Yeah, exactly.
All right. We have a couple of other topics today. I just name them now, and Christian, I'd say you decide which one would go first. We have. I would like to talk about what Wolfgang did this week with the object detection. I'd like to talk with. Pardon me? Okay. I would like to talk about Beak's initiative towards data external data structures and data maps, but we shall keep this until Lionel comes up, because Lionel had some ideas as well. Yeah, and then the last thing maybe we can discuss Wolfgang's concerns about the PT set cover, but this is, let's say, it's not important at the moment because we're not working on it, but it's just a topic we can discuss later on if you all agree to. So for now, I'd say we can go on with the topics that Wolfgang raised this week with the object detection, and especially with the video that he recorded, the snippet you recorded, Wolfgang, and put on Discord. My first question to you, Wolfgang, was you don't record.
He's not in.
He's not there?
He's not in.
Wolfgang,
No.
are you there?
I'm here.
Yeah, he's there.
Yeah.
So Wolfgang, can you explain first? You said you do not record the original video. You don't save the original video, right?
Yes.
Okay.
Yes. I don't save the original video, so I use the stream, the 12 megapixel stream, and then I'm scaling it down in several steps. So the first step is done at. So I'm blurring the original image and then I scale it down to half size, and then I do the object detection, and the last step, the tracking, is done at 750 pixel size, because I think that's enough for, and it reduces the amount of data. So the tracking is done at the size you see it in the video. So maybe it's a little bit complicated, so I have to write it down, I think, and make a document. But yeah, it takes time.
So okay, first of all, you've got a 12 megapixel camera. So let's assume it's 4,000 by 3,000, for example.
Yes.
Okay. And then you start blurring it. Why do you start blurring it?
To reduce the noise. So I think that's the standard procedure for any further detection steps.
This part gets rid of the edges. Normally, you would have to do some kind of edge detection, like a neon filter, and this takes a lot of time to do it frame by frame, and you would have to do it. And by just blurring it with a Gaussian filter, you get rid of the noise, but you soften the edges.
Yeah, slightly.
It helps when you have to sample it down, because the hardware can't cope with 12 megapixels.
Yes,
we discussed that in the members meeting today, and we are looking for a solution that can handle such kind of let's say 20 megapixel camera feed.
Yes, that's the reason why I'm doing this blurring. It's only a slight blurring, I think, and then I'm reducing it to half of the size, so to 2000 by 1500, and then I'm doing the object detection, and this is working very well. So I can detect sometimes I can detect objects which I cannot even see with my eyes, or only if I look very intensive at the spot, then I can see it. So I think it's not so bad. So I can detect airplanes, I can detect even stars and satellites at night. So ISS is absolutely no problem, and also some stars I'm detecting. So the brighter, the more, so the stars which are, for example, Sirius.
Okay, for the stars, we have a very high single to noise ratio, so
Yes.
it won't be a problem to that.
Yes.
The blurring is doesn't affect the intensity of an object. It
Yes.
just affects the flanks
On the edges,
and
yeah.
the static around that.
I know. So, yes, of course, we have to try. So, but in my experience, so I'm using the software since some weeks now, and I think it's at least for the start, it's not so bad. It detects many objects, and it can also the tracking and the object detection is so it doesn't track clouds, for example, or very rarely it's tracking clouds. So I think clouds are the biggest problem. So it's no problem to track airplanes. So why not getting pictures of airplanes? But clouds are the problem. And I think that's the biggest challenge to get rid of the clouds and to detect most of the other objects, or as many as possible.
So my question to you, Wolfgang, is I understand why you do the blurring. Do I understand the half sizing, which is only due to the performance from your host PC where you process that? Is that true?
Yes, I'm using the Jetson Nano.
Okay.
And I'm getting about 4 frames per second processing speed. And if I would do it with the full resolution from start to the end, then this would not work out.
Okay.
Yeah, this is a confirmation about what I got as a result.
Yes.
The Jetson Nano can't handle 12 megapixels. 2 works good at up to 20 frames per second. 4, I have about 1 to 2 frames per second running without the just P-frame version. Yeah. So I can confirm what you find.
Yes, and I wanted to have some. So I think 4 frames per second is okay, but if you have only 1 frame per second, that's not enough for tracking. It's useless.
Yeah.
So I had to make some compromise because I don't have any better hardware at the moment, and I think so that's my general strategy. So I have to use what I have, and then I have to look what I can do with it, and use it, and then improve it. So I think you cannot go for the maximum solution, whatever, and then at the end you will have nothing. So
your strategy is totally fine. Absolutely, no worries here. I just question what you did to understand what you did.
Absolutely okay.
And your 4th step is to reduce it 750 by 750. Can you explain that one?
Yes, that's after the object detection. First I'm doing, after the blurring, I'm doing edge detection. Kenny edge is it called? I think you will know it. It's a standard algorithm from OpenCV, and so that's the edge detection. Then I'm making a delayed filter, so to get if you have the edges from the edge detection, you only have singular, or you only have a thin line of pixels, which also can have gaps. And then I'm doing a delayed filter to close the gaps so that I get solid structures. And then I'm downsampling it to 750 to 750, because then I have the solid. So even if I have an object which is only 1 or 2 pixels, then after the delayed, it has many more pixels, about 10 pixels maybe. And then I can scale it down to reduce the further processing. without losing any information.
What further processing do you mean? Why is there a
So
need to downsample?
the tracking. So then I'm doing the tracking. So first I have only objects. So I'm not doing motion detection. So I'm doing object detection. I also detect stationary objects. And then for every object, so every object is in the beginning is a track in the beginning. And then in the next frame, I'm looking if the object has moved or if there is another object near the end of the track. So then I assume, okay, the object has moved, and then I append it to the existing track. And then I'm evaluating. So after the track has at least 10 points, so then I'm evaluating the track if it is plausible. So I'm checking it if, for example, if the object is only jiggling around and does not move in a smooth path, more or less. And then I keep it or I discard it. And I'm also discarding all objects which don't belong to any track. So if they are far away from the endpoint of a track and only appear once, then I discard them.
That's noise. Clear.
Yeah.
And
so that's basically the strategy. Yeah.
So the object. So do you do this frame by frame? Is this true? So the object detection on the 2000 by 1500, and then the reducing and tracking. You do this frame by frame. Okay.
Yes.
Okay, got it.
For the motion detection, you do not need such high resolution.
Yeah.
Because for the object, for the object, you need let's say some kind of aperture around the object that you can get some kind of geometry from, and this is basically the thing why you do the object detection before the motion detection.
Yeah.
And with the approach that Mike G was doing, he tried to do that in one step: object detection and motion detection.
I think he used
this is what basically the neural network should do.
No, I think he used optical flow.
No. He tried Paul Lamter was using the optical flow. Mike's approach was basically going in another direction where the video performance, the video stream performance, tries to opt out jiggling around objects. I think it was. What was it called?
Background subtraction.
No. It was not the OpenCV version. It was some with video. Don't know if I wrote it down.
We have to ask Mike.
Yes. By the way, how's he doing? Did anyone hear from him?
Mike, if you see this video, we are missing you.
Yeah.
So I have two questions to Christian and Wolfgang. So the incoming stream and the issue with this for being on a, let's say, Nano Jetson platform and not being able to process it in the full resolution. And the second is the result of the object/motion tracking, which is then going further on, let's say, to Lionel for classification. So, first question. Christian had the idea to use, what he's now working on is creating the stream on, maybe Christian, you can explain in detail what you are doing to create the stream, and what the idea is then to extract the P frames to get a smaller aperture, which is then processable in, let's say, full FPS on the Nano, or almost.
Yes. Okay. because I had the same problem that Wolfgang has to provide a suitable stream that can be handled with a Jets Nano, I was thinking that just recording or getting the stream with a Pi 4 is the best solution because it can handle up to 20 megapixel cameras. And this with up to 60 frames per second because the Pi 4 is basically designed to be a multimedia server. And therefore it can handle very high frame rates with very high resolutions. Because let's say 16K broadcast cameras can be used with it too, with 60 frames per second. And my actual approach is using the Pi 4 as a buffer to the Jets Nano and letting the Jets Nano doing the neural network stuff as
And the
machine
motion,
learning.
and the motion detection.
Object detection, motion detection, and classification.
Yeah.
Because this should be done with a neural network, and one can increase the quality of Wolfgang's process by putting that into a neural network. So my idea was just using the P frames because these are the differences between the normal frames. If let's say if the background is smooth and you have got the iframes are the keyframes, this is just an image taken. The next image, there you've got all the differences from the frame prior to that, from the previous frame. And if you those P frames are just a slice of it. Let's say you have 4,000 by 3,000 in the iframe, and just the chunk of this P frame is about, let's say, 300 to 400 pixels. Then these 1,200 pixels will fit into the buffer of the Nano and then can be processed by the graphic card on the Jets Nano. So the reduction of the data load sets in much earlier by just feeding those P frames to the neural network, and not going having to go through the whole part of blurring, sampling down 2 times, and having then let's say 2 informations, but with processing time in between. So if you can do it at the same time with a neural network, with only the P frames, then the whole process will be speed up and the resolution remains the same as before. This is another approach. It's a different way of doing things.
Okay.
The classical way Wolfgang described and is running, and yes, you do object detection and afterwards the motion tracking. This is done just by CPU. And because you have to do it, or you are doing it with the CPU, then you have to do the downscaling. And if we want to avoid that, then we should reduce the data load with other methods, like the described one.
So, Christian, any idea who or when we can start having tests with the P frames?
This, I would say, depends on what Mike G can provide, because he put out a simple tracker version. I do not know if he succeeded with his video library method at all, and since we haven't seen him for the last 6 weeks, I don't know in what state that is, but
okay.
I was focusing on the performance part 2, having his approach in mind, and we can go both ways, I would say, and then see which one works out the better way.
Yeah, good point.
But having the performance part already helps both ways. We can use it, and Wolfgang can try to use the p-frames too, and to speed up his pipeline.
Wolfgang?
Because you only have to take care of the differences, not the things that remain.
Yeah, I think we have to talk about this once again. So I have not really understood all the details, I have to admit, but maybe we can.
Yeah, we're doing this in a very small group.
Yeah. So I think at the moment I can live with what I have. And then if there is a better way to do it, it's fine. And
this is not a better way to do it. It's a pre-process so that you do not have to rescale.
Mm-hmm. Yeah.
It's just reducing the aperture.
Yeah, because the rescaling. Yeah. So if we can achieve it, that we have the object and motion detection at the same time, then we have a speed up. So it's an improvement, but there are two ways one can do that, and I think we should go both ways and see which one is more suitable.
Mm-hmm.
But both ways, they
German?
The word is missing.
What is German?
Profitieren.
Make profit on?
Yeah.
It helps.
Christian. Hey, Christian, I have a question for you.
Go ahead.
Okay.
What you mean? What you mean by object detection compared to moving detection?
Object detection means that you recognize, let's say, a tree as a tree, and movement detection means that this object, let's say, moves
and looks
in difference to the background of the image. So if let's say you detect a car as a car because it looks like a car, and then you can say, okay, you've got an object, this car, and this car is moving from one side of the image to the other. So this is a difference. And the normal approach is that you detect an object first and then take a look on how it behaves.
Okay.
So we don't need, in order to do these two things, we don't need high definition.
For the geometry part, yes, we need resolution. For the movement part, not so much. That's why Wolfgang set his pipeline up like first detecting the object, then looking on how the, let's say, the center of the mass is moving
on a lower resolution.
Yeah, because all those objects do not have a very high movement rate, and they do not turn, let's say, they do not make a 90 degrees turn within a fraction of a second. This will be hard to determine. So the Richard provided a video where you can see that an object is doing such a movement path, and it would be nice to see if Wolfgang can track that object. So Wolfgang, could you take a look at the video Richard provided and run it through your algorithm?
Is it on Google Drive or?
I think yes. Yeah.
First of all, we have to know that Wolfgang is using the stream directly from the camera. So Wolfgang, what you have to do first is that you also use MKV files to load and process, which you don't do yet. You told me.
Yes.
Okay.
I could use a video file. Yeah.
Okay. So the thing is, we have a huge repository of material that should be our training material or work developed material. It's 1.2 terabytes, and Mike took out a big portion of it and processed it already, and this is to be found on the drive, and you have already access to it. It's under software/ML. You find all these videos and his results from his processing. It would be good if you could take such material, that's all MKV files, and process it via your code and compare with the results that Mike put there. That would be one interesting thing. And one of those videos can also be the video that Christian now mentioned. The other part, which is also interesting, and maybe we can also put this to you, Wolfgang, is the result of your motion detection basically is a bounding box. And you provide certainly kind of a vector to that bounding box frame by frame. Is this true?
Yes.
Okay. Because Lionel needs this data, this output. He has only output from Mike up to this point, which is on the drive, but he would also need it from your side, from your code. So if your code produces bounding boxes with vectors, he would prefer to have these vectors to the center of the bounding box, not to an edge, to a corner, which is with Mike's result. So
that's already what I get. Yeah.
Okay, perfect.
I get the centroid of the object.
All right, perfect. So that's
because the OpenCV library does that in the first place and doesn't go for the edges.
Yes.
So my question to you, Wolfgang, is: can you change your code in the way, so first of all, that you can read MKV files, and for second, that you create bounding boxes that you can store somehow in a JSON or whatever, so that Lionel can pick that up? Perfect.
Yeah, I can try.
Perfect.
Lionel is to the vectorization part. So to get one day to get some kind of movement path that can be translated and transferred as an intercepting course for the PTZ cam. This is basically what's behind that. So he's doing the vectorization.
Yeah, but it's not part of the ASC. Vectorization, we said, is part of the MCP. So what Malayalam is doing on the ASC is classification. So it's a kind of a pre-classification before going into the neural network classification.
Yeah, because Paul Lamter is taking care of the classification when he's ready with the pre-selected materials.
Yeah. So this brings me to the next point, addressing both you, Wolfgang, and Christian. When those bounding boxes are created, you can extract those bounding boxes and the video material in it. So to create, and this is now my question to you, what makes sense, to create an extra stream that can be processed by the neural network on a much smaller aperture. So let's say if the bounding box is, I'm just naming something, 100 by 100 pixels, for example, and there is a bird, a plane, something in the middle, and you create a stream out of that one, first of all, it would be a very low resolution, just 100 by 100 pixel video stream, which can be very easily, I'd say, being processed by neural network.
Yeah.
So the result of Wolfgang's bounding box is not also helping Lionel, but also providing a stream for the object detection, recognition, sorry.
That was basically the idea.
But I wonder what we want to do with the artificial intelligence, because most of the objects are only some pixels. You cannot tell if it's an airplane or something unknown, or maybe you can tell if it's a helicopter which is flying very low, or if it's a bird, yeah, that you can see. But most of the objects are only very few pixels, and I see no point in doing some classification with this data. So I think to answer the question if this object should be tracked, can be done by the motion of the object. So how it's moving, but now how does it look like in the low resolution picture from the fisheye camera?
That's why we want to bring up the fisheye camera to have high resolution.
Yeah, but
therefore we need hardware and software that can cope with it, and this is what we are working on at the moment to get a video stream in high resolution for that part.
But now we have about 9 megapixels for the center part, and even if we double the resolution, we would have about 36 megapixels or 40 or whatever, but it's not so much more. So the object still is only some pixels. So you cannot see if you have an airplane which is flying 20 kilometers away, you cannot see the wings and the tail, and even if you have upper resolution.
In the beginning, we thought of having one algorithm that is run on both, on the stream that the ASC is providing and the PTZ cam, so that we do not have to code and to develop two processes of the same kind. And so the idea was that we just optimize the input stream for both, for the ASC and the PTZ cam. So if the algorithm can handle high resolution with high frame rate, then we do not have to develop two different kinds of neural networks.
Yes. For the video stream of the PTZ camera, that's okay. There you can do very good object classification. Yeah.
Yeah, and if that works on the all-sky cam part 2, then we would save 50% of the development time, because we just have to develop it once. This was the basic idea behind that approach.
Yeah.
There's another basic idea. I mean, if I may mention that, it's the reason. The reason is because there's not only one event at the same time. When you see one of your videos and your motion detection, Wolfgang, you see that there's much motion. So you have always a bird and a plane at the same time.
Yeah, sometimes also it's jumping. Yeah, it's jumping from one track to the other, because I at the moment I do not identify the tracks. So sometimes, I'm always displaying the first track, and sometimes the second track becomes the first track, and then
if they cross lines, for example, yes. But the thing is, the basic fact is that normally there's not only one event. Normally we always have multiple events. So we have only one PT set, so we can only control one PT set to steer to one event. So which event?
Yes.
The first event? Always the first event? No good decision. So we have to find out which of these events is the most interesting, let's say, to be guided the PT set to it, to take a close-up look at it. In order to, if you, let's say you have 10 events at the same time, in order to know, to find out which of these 10 events is the most crucial one, the most interesting one, you have to know somehow what it is. So maybe if you can say it's a bird in the first place, let's say by kinematic classification, because it flies like a bird, it has this shape change between flaps on the body, flaps outside the body, and so forth. Maybe the classification can already say, oh, this is with high probability that's a bird. So we skip it from the list of events that the PT set shall follow. But maybe there's another object that the classification can say, I cannot say with high probability what it is, so it's not really classified at that moment, because let's say maybe it's a 50% probability, which doesn't make sense to call this classified. It goes to the next step, which is the neural network working only on a small aperture. Let's say I said before I said 100 by 100 pixel, but just call it, let's say, 64 by 64 pixels, so it fits into the GPU very easily. By then you have, for example, an Airbus represented with 10 pixels, for example, within your 64 pixels, which makes a noise to signal to noise ratio rather high. It does not mean necessarily you can take the same neural network and use it for the PT set. Christian, I'd say maybe the procedure towards this neural network may be the same, but the neural network itself will certainly be maybe more sophisticated.
If the resolution of the input material is high enough, you can make some geometry analysis and say, okay, this one is let's say an an MD11, or it's let's say 757. That can be done with the images of the ASC already.
So
Wolfgang sent me a very good picture of a helicopter that covers, what was it?
Yeah, but this was flying very low. It was flying very low. Yeah, but this image was from the, not from the PT set, but from the simulated PT set camera.
Yeah, but
yeah. Mm-hmm.
If the resolution of the AllSkyCam is high enough, we can do some pre-calculations. We can do some pre-classifications, identifications, and that reduces the workload that the neural network and the steering, the slewing of the PT set reduces to only the very interesting objects that can't be identified.
Yeah.
But my strategy would be to do this AI stuff and this sophisticated processing, to develop this at a later stage. So my strategy is to get a tracking which is good enough to get rid of clouds, for example, and to get some objects, and then to build the PTZ camera, to use it, to look what I'm getting, and then I can see, okay, I have to improve this and that, and so and then I would start developing some AI and whatever to improve this.
Let me stop you right there. That's why we split it up into teams, so that they can work in parallel. So one team is just focusing on, let's say, the tracking stuff. Another team is focusing on classification. Lionel, for example, is doing the vectorization part. I'm doing the part that leads to a high quality video stream that is that can be processed with the hardware on hand. And so because we split up all the workload into teams, we can work on it in parallel.
Yeah.
So your part might be the one path that is parallel to Mike G's part. So if we are going down both ways and taking a look what plays out much more nicely than the other one, we can say, okay, can the other part benefit from it, or can we put them together to achieve things, let's say, much quicker than this splitting down into teams benefits. The whole project benefits from it. So yes, you should go that road and take a look at what the algorithm you have on hand can do, where the limits are, and see where you can optimize it.
Yes. So, but so I think that has some historical reasons. So I was working for 25 years as a one-person team. I did everything. I did the mechanics, I did the electronics, I did the hardware, software, everything. And that's how I work. And so, of course, yeah, I also can work in a team, but sometimes I have some strange ideas, and then I want to do it.
Yeah.
And this is what I'm doing. So at the moment I'm already building my PTZ camera.
Oh, okay.
And maybe you will like it, maybe not. But I think that's the way I'm going, and I'm also can integrate, of course, some of the software the teams are working on, and I can also provide my software for the teams. And then I think we are getting the most synergy effects.
Yeah. That's why we said, okay, let's put all the things we have on mind together.
Yes.
Sometimes I'm working on the PTZ part and thinking, okay, this camera might be much better than that one. And 5 minutes later, I have an idea on the video streaming part. And yes, I know that because I'm doing the Lonely Warrior myself for 20 years now.
Yes.
So I can understand you completely here. And but at the moment, we have the chance that we can give that up, that we can be part of the team here. And look around the people.
Yes,
they play nicely together.
I'm trying to
every idea that you come up with and discuss it with someone may help you your part of the project as well. And let's say when we talked with Rebecca about some ideas of how the GUI may be, then I got some ideas on what concerns me on a completely different level, and this was very nice to experience. And so we benefit all from that.
I'm trying to do both. I'm trying to work in the teams, and I'm trying to work outside the team. So I think I have enough time and resources to do both.
Yeah.
Perfect.
So
okay.
Yeah.
So
I talked with, for example, I talked with Bojan today about digital signal processors versus digital sound processors. This will come in handy when we add the software-defined radio part, because if we can combine the optical part with, let's say, transponder signals, then the classification goes up in certain levels. But someone has to do that.
that would also be a part which is interesting for me. I also have a ham radio license.
Guys, sorry, I have to interrupt
Yeah.
you at that point. So this discussion goes off the road.
Yeah.
I take it.
By the way, forget about it about this Freescale chip and DSP. Not gonna work. I went through the data sheet.
Yeah.
Doesn't
It's too
have
low level.
ability of DSP,
Yeah.
but is on another side is better. But DSP is not problem. Microchip has nice DSP chips. So if we need it in the future to processing sound or analog signal,
Most part for the converting, but it's not at stake here at the moment. Yeah.
Yeah. But speaking about this Teensy 4.1, forget about the DSP. But on another side, we can do other stuff. Yeah.
Okay.
Okay. I think Rebecca's turn.
She's not there.
I'm here. I've been listening.
Oh.
I'm here.
In disguise.
Exactly. For me, I wrote down my list, so I'll just go ahead and read it. This past week, I set up the Django portion of the site with its libraries, and then the Node portion of the site with its libraries. And our APIs will govern whether we need Django or Node, but again, hoping to rely more on Django. Let me see. So I was working on adding the libraries for the Neo4j database. So I'm new to that. I don't know too much about it. I still have to read up on it. I had a couple of problems getting 2 libraries installed. There were errors coming up on that. So I'm hoping that that's something that's going to be worked out within the next few days, and I'll just follow up. Maybe it's something with the libraries that, there are errors in the libraries, it looks like.
Okay.
Yeah.
So
I'm convincing them to, yeah.
Okay. And so I'll follow up on that. And if not, maybe go to GitHub and get a copy of the prior version, possibly. I don't know if that's available or not. And then for my plans for this week, it's a lot. I always like to overplan. I know I won't get most of it done, but I wanted to then add Postgres and PostGIS to the Django site. I wanted to add Jannik's weather API code that he has on GitHub. I wanted to add that to the Django portion of the site and see how that looks. Let's see. I wanted to transfer Brandon's camera code that he completed and put that on the Node portion of the site. And I think he mentioned that he was having some issues with actually saving the PNG file for the mask. So I wanted to work on that.
Okay.
Brandon just came back from vacation. He's still getting up to speed, adjusting to the work-life balance. And he and Josh had plans to get on a phone call together to start talking about the work that they're working on, since a lot of their code is going to sort of work in tandem with each other. So they're doing that. Let's see. And for the Neo4j database, I was kind of curious. Well, I'm trying to see how it's working in my head, how it's going to work out. It looks like the data is going to be downloaded from the Sky360 station onto a portable solid state drive. Is that right? And then they can transfer it to their home and look at it through the GUI. And so they'll need to upload it back to, or actually use it from the solid state drive.
Both ways are possible.
Both ways? Okay. And so
you can think of and try each one, and it would be interesting what you find out and what you prefer, and just take a look at what's best.
Okay. And I haven't looked at all of Neo4j, the documentation or anything, but you can also download that data in a CSV file. Is that right? I'm assuming. Do you know?
Yeah, comma separated value, yes.
Okay, because then I might want to re-upload it into a Postgres database. That's why. So because for me, I want to use Postgres a lot. So I think.
Postgres is a sequential query language database, and therefore you have to produce queries, and this is real time ready. I would say go the other way around. If you have something in Postgres, put it to the graph database because it's accessible in real time. And you do not need any query because you already know where the data is stored.
Oh, really? Okay. Now I haven't used Neo4j database, so I don't have a picture in my mind of how it works. So I'll have to try it out, to see what you're saying.
If you need an image of that, think about a tree, and a tree has the nodes, and you know where each path down the tree is heading. And since you already know that, you do not need any query. You do not have to ask the way and do decisions. So you do not have to look or search because with the data, the path to it is already stored. And this makes it real time.
May I interrupt with a question at that point? Do we have already a data structure for Neo4j set up somehow? Is there a UML file? I think we do not have that yet. Christian.
Yeah, at some point we have to bring all the data we have on hand into that database. And I think this is a workload that can occupy 2 or 3 people at the same time. And but it's good that Rebecca started going down the way of the Neo4j part. We have to acquire some people to help her with that.
Okay. And for now, I'm just using mock data anyway. All of that can be removed.
Yeah.
Okay. And then, let's see. Oh, and also, for those people that want to just use a GUI that they download and install and, use, then I'm also going to be working on PyQt6 and seeing what I can do with that. So that way we'll have, the 2 different options. I'm thinking maybe some people might be after they've set up that entire Sky 360 station, maybe they just want an executable file that they can just install and open up. So I'm doing that as well.
Okay. Yeah. Maybe skip that for, let's say, the next 2 years, because
2 years. Okay.
Yeah, I think we won't need that because you can run the web GUI locally. I don't think there's a need in having an offline version with a completely new frame set around it. I think we are doing fine if we have it browser based. Because Django offers some things is much more, let's say, up to speed right now. What can be done with the GUI and the graphic part, and I think we can skip the PyQt6 part.
Okay, so it suits us better than the other than PyQt6. Okay.
Yes.
And so for right now, that's all I have to share. That's where I'm at this point.
Perfect. Thank you.
Yeah.
So.
Yeah, I have to say, you all did a very great job last week, and especially Wolfgang and Rebecca. That's.
And Jannik.
Yeah, and Jannik.
May I raise the next question towards external data maps? Because you both mentioned it. Jannik, Rebecca, there was a discussion in the Discord channels the last couple of days about external data maps. Anyone wants to mention that work or the topics around that?
I think, Rebecca, you can talk more better about that, more knowledgeable about that than me.
Okay, maybe I need to refresh my memory. Is this when I was talking about neutrinos?
Yeah. You were talking about a global neutrino map.
Okay. Well, I wanted to see if I could find like a rasterized map of neutrinos, which is it's not like a PNG file. It's a file that contains let's say you have a 400 by 400 pixel sized image of neutrinos overlaid on a city. So that way it'll tell you if there's a lot of neutrinos in one section, less in another section. That's just an example. And so each pixel will have a geographical location marker. So that way
is so important.
Well, just that I read somewhere. Well, I think everybody.
Neutrinos are a fission side product, let's say. So if we assume that UAPs using a kind of, if fission happens somehow, or their process is producing neutrinos in whatever way or form.
How do you separate sun-induced neutrinos from UAP-induced neutrinos?
You don't. You just look for correlation. It's like anything else, like weather data. It's corollary only.
But I mean, neutrino is neutrino. You can figure out where is coming from.
You can do some density analysis about them, yeah. But since they don't interact with normal matter that recently,
A neutrino exists in nature, right?
yeah,
Naturally.
but it doesn't interact with normal matter that much.
So?
I was thinking, I was looking at those maps, and like Wolfgang pointed out, they're models, but they're kind of based on other experimental data. So it's kind of, how do you say it?
Experimental data, not really
yeah.
reliable. Yeah.
Mm-hmm.
And the thing. Sorry, go ahead.
And sort of a not direct knowledge of the amount of neutrinos, but indirect knowledge of the possibility of neutrinos in a particular area. If that makes sense, like an educated guess at how much the neutrino count is in a particular area.
Yeah.
So it's a good.
So the map is direct interpolation from monitoring stations. It's,
But I think what they are doing, so what I understood from the article, they are using normal measurement devices for normal radiation, radioactive radiation, and then they have models about neutrinos, because you cannot detect neutrinos with normal.
That's my point.
You need neutrino detectors. They are huge volumes of water, and then you get 1 or 2 detections per day. So, and this.
That's my point. In that article, they point out that they assume that some kind of radiation radiates neutrinos, and that they are in a certain amount available.
So there are some portable neutrino detectors. I know about them. So there are different kinds of neutrinos. They are from the sun. They are very difficult to detect, and I think the neutrinos generated by nuclear fission in power plants, they are more easy to detect. So there are some detectors which you can drive around in a van, for example. So there are these detectors exist, and I also know that the military has planes with they have neutrino detectors to detect nuclear warheads.
Mm-hmm.
This is possible. So they can fly around and detect nuclear warhead. But this is technology which we will not get in the next decades, I think.
Neutrino cannot be sourced by nuclear reaction, right?
Pardon me? Once again.
Neutrino is not only can be found from nuclear reaction, right?
From any kind
You
of
have
nuclear
different
reaction.
process.
It's not that it only occurs from decay, but from fusion too. Yes, both ways. But the more interesting part about the neutrinos, or having a map about it, is whether you can do some kind of density analysis and say, okay, this UAP emits them by some kind of, let's say, engine or force field that it is creating. Or you can say, okay, the force field that is creating denses them. Therefore, you can use some kind of map, but
the map is the sticking point for me, because you have to consider the length of time and the size of the phenomenon you're observing, right? So if your map is recording and interpolating neutrino densities over a coarse time frame and over a coarse spatial focus, you're not getting anything. You've got a map with a raster with data points, just like a digital elevation map. Yeah, which is great, but when you're actually trying to correlate it with the scale of your observation, those two don't match at all. So it's really, even if you have a map and it has data on it, it doesn't necessarily correspond well to what you're trying to analyze. So I think when we're thinking about things that we could collect corollary data on, whether the weather, what these background databases exist, the scale of the observation has to be commensurate with the scale of the map and the scale of the data, or you're pretty spurious correlations.
I was just sort of thinking of that map as an educated guess of the amount of neutrinos in a person's area, to give them an idea that maybe that object, since it is attracted to neutrinos and you have a red level of neutrino in your area, for example, then that's a possibility. But then also, I think Richard also pointed out a link in the Discord about muons or muons. I'm not sure how to say that.
Muons.
And I was reading that, and it sort of mentions something about muons turn into neutrinos sometimes, not always, but maybe that might help somehow. I don't know. I haven't investigated the idea any further than that.
All the most, let's say, well-known muon that's in this universe? The electron. And you only have 3 muons. It's the electron, the tau muon, and I think it's the down quark. And all those 3 are very, the electron, okay, we can detect it. The tau muon is detected, let's say, in the Fermilab at the moment. And
But there's
somehow the muon breaks down somehow the muon breaks down into 3 different things, one of them being neutrinos. So maybe if you have a high number of muons, then you have possibly a higher number of neutrinos.
Does it really matter? I mean, at the point, what the guy that did the muon detector did is he uses a silicon plate that excites energy by having a muon hitting or passing through, and he uses simple camera sensors just to detect whether there is a little count of there must be some kind of a muon in any shape or form reacting in the silicon.
Yeah, I have looked at the video. So he's using a scintillator. It's basically some kind of plastic, which has a special substance which generates light when the particle interacts, and then this light is detected by some kind of photodiode. It's an single photon detector.
But think about it. If let's say you have an electron is emitted somewhere and from, let's say, hydrogen, and then you've got the Balmer series, because this electron is put on when it's activated on a much higher energy state, and it emits light when it falls down to its normal state. And since an electron is a muon, then hitting some kind of plated whatever will emit an electron, which does exactly that what I just told you. So what of the three muons do you want to detect, or can you detect? It's only electrons, and giving up some kind of photons with a certain radiation energy. So the others, the tau and the down quark, are not detectable by that.
Actually,
because therefore you need
Christian,
you need some kind of decay.
we don't care about this. What the guy, this MIT guy, proves is that he has somehow assembled a muon detector, whatever form or shape that is, but he can.
I doubt that
combine.
highly.
I have a question, because neutrino is basically neutral. Let's say not positive, not negative, right?
An electron?
Yeah.
What kind of information we have from neutrino?
It doesn't interact with matter that very much. It is, let's say, 1 to a million that it interacts with matter. It passes through matter undisturbed. So don't bother about neutrinos. That's why you need such huge containers to detect it. And I think the muon parts is the same.
Why?
Having just a small, somewhat detector that does it so easily, electrons you can detect very easily because of the photons, the interactum quantums are photons, and they radiate, of course, light.
In the case, what this MIT guy did, he encapsulated it in a plastic wrap and in a little compartment, so a little enclosure. So there's no light that goes into. There must be
Doesn't matter because the photon is radiated when the electron falls to a different state of energy.
Exactly, that's his measuring procedure. But the good thing is that he can combine two of those measuring devices and stack them, let's say, in a certain distance, and then by software he just reads out both of them, and if both have the same narrowness of time, so let's say both within some nanoseconds, then he says, okay, there is a muon walking through.
This is what he proposes, but of course it is a muon.
It's
called
high energy cosmic rays. Yeah, it's cosmic rays somehow.
So the question is, if we take such two devices and put them in a, let's say, 20 centimeter distance or whatever have you, put them on a PT set and point this towards a UAP. The question is, what do we read? I mean, we don't know yet.
The same as you pointed to everything else.
Are you sure? We don't know yet. Why are you sure?
Because
the
this
UAP blocks it? What if the
What
UAP
you
blocks
say?
it?
What do you say?
Maybe the
if-
UAP blocks it. It goes around the UAP or bounces off the UAP. I don't know.
Then you would detect it anyways. The question is whether the UAP emits it so that it has more signal towards the background noise. That's, for my point, the most interesting part.
But I think it
Uh,
must be very, very close to that you will be able to measure something.
like heat.
But it's a geometric question. If I have two optical sensors, which are tiny, and I put them on let's say 20 centimeters, maybe half a meter, I don't know. So if I detect two muons, which are events that are not very often detected with these sensors, but when you detect them in both at almost the same time, then this is something that's coming exactly through the axis of his setup.
Yes.
I think you're missing the point here. A muon is an electron. You can detect electrons all the way in this universe.
So
But what the
question is
MIT
his
guy is
setup.
referring to is something different. It's the tau muon.
Anyhow you call
And
it.
that
Maybe
you
you call
can't
it.
detect by such a device.
You can't
Because it
detect.
doesn't
So
interact with it.
What do you say? What he's detecting?
Electrons, just noise. Electrons and photons that are falling back by the change of the energy state the electron is in.
And if I take two of them and put them in
It doesn't matter. It's just an electron changing its energy state and radiating a photon.
If
That's done
whatever
in
you-
LEDs. That's done in every electronical device we use.
Christian, but come on, this is logic, yeah? Whatever emits this, if I take two sensors and I have the same event at the same time, I'm there, yeah?
It isn't, because you can't, if you detected it in one, you can't detect it in the other.
Why?
Because it gave up its energy in that detector.
That's possible. So this
Then he does that.
this radiation has so much energy that it can lose multiple times some of its energy.
I would say so.
Yeah, and then it's a cosmic ray.
That's a cosmic ray. Yes, he's
Yeah,
detecting
and then it's no muon. Then
maybe
it's a photon with over light speed.
Yes,
Christian,
yes,
whatever
yes.
you call it, yeah, call it Mickey Mouse. If you
It's
take two
cosmic
Mickey
ray.
Mouse sensors, and I have two sensors, optical sensors inside, and they detect the same event closely together in the same time scale, I could say that it was emitted by the object I was looking to.
But it's not doing what the MIT guy says.
I don't care.
His
what-
experiment
I don't-
his experiment does something else.
Whatever
It's
he
detecting
does,
cosmic
whatever you call
rays.
it,
Yeah.
it does detect something. My question is, if I take two sensors that detect something, whatever that is, I can say it comes from the point I'm pointing to.
No, you
Why
can't
not?
say that,
Why
because a cosmic ray can be emitted anywhere, and it
If-
has.
If I point such sensor configuration in the sky and I detect, let's say, a cosmic ray
Then you don't know its origin.
Just once
You
a
don't know
minute.
its origin.
Christian, I don't care about the origin. I'd say I detected this Mickey Mouse. I detect this Mickey Mouse once a minute. But if I point it towards a UAP and I have a reading rate of 1 per second, then it's a difference.
You won't get that reading
It
rate.
still have to be tested.
Okay, then let's test it.
No, I say we leave particle physics out of this and get to the fundamentals and just get a working station, please.
Yes, you're right.
Okay, so
Our install a Fermi lab.
We can do that as a side project with, let's say, a budget of $2 trillion.
Nah, come
Yeah.
on. Just to test what the guy already did is an investment of, let's say, $200. So, if someone
okay.
is interested to do it, I'd say bring it up and test it. I mean, what can you lose?
I think
Time.
Our problems is we trying to detect something in a traditional way.
Yes.
Yeah.
Not gonna happen. Not gonna happen.
Yeah, that's Bojan, you have actually a good point, Christian. Listen, we don't know what we do not know what we even do not know. And so we have to test everything that is somehow feasible. It's from my point, it's unfeasible to create a neutron detector because it must be big and so forth. Yeah? It's just not feasible to do it. But the simple muon detector.
A neutron detector is simple. Just take out some aluminium and put some graphite on the other side, and you have got a neutron detector because one side heats up, the other stays cold.
Looks to me, look that. I'm trying to measure voltage. Okay, this is traditional way. I can do it. But we trying to detect a UFO, UAP in a traditional way with fluke meter. Not gonna happen. Period.
And we need if you
I see your point. It's pointless to do it with the traditional sensors. Yes.
No
And
way.
doing it with indirect measurement, it's the same. That's why we opt out the FLIR cameras already. And I think it's the same with approaches like that, muon detection, everything like that.
So I think it's
We
important
must
to...
have a distant field detector for that.
Okay,
And
it's important to everyone understands that we're talking a 30-year game here, and our daily development is much more focused on the shit we can find on shelves, and we don't have to invent. So I just want to make sure everyone's clear. We're talking two very different timescales here.
I think we should stick to the optical methods first.
Yes, we do that.
Yes.
Yes, we do that in any way, Wolfgang.
That's why I like that map. That's why I like that map. At least it's the start, and you can, with the map, if you have the geocoordinates of all the neutrino counts, then you can at least say, in aggregate, this area has a high neutrino count and a lot of UAPs.
Yeah,
so
see that hypothesis testing there that corresponds well with the scale of that map. So not trying to correlate individual events that we're observing, but I mean you're looking at like the 10,000 foot level where you've got a bunch of observations and you're looking to see if they group in a particular area in which that map would facilitate.
Yeah.
Hey, Brad, I need to distinguish something. We using traditional way, for example, climate control, controlling PTZ, blah blah blah, camera. This is traditional error, but we need to also look on another way to detect the objects.
Oh yeah, I 100% agree, but it's just the practicality of developing this.
Yeah, we developing our traditional technology using the software, hardware, whatever we have right now. But also, we need to look further. This is our way. We cannot say, "Oh, okay, I stop there. I don't know what's going on." No, we're gonna use maximum of our technology today in order to detect objects, whatever they are. But also we need to look further and, thinking about we don't know what we're dealing with. Period.
Yeah,
right?
I mean, and you have to start with what you have, and you make observations, and then you don't ever really solve it. You just create more hypotheses. That's the process of science. I mean, we're describing the process of science here.
Yeah, but that's why is this discussion very important today, to get some ideas, neutrino, whatever,
Yeah,
we gonna go further,
You could realize sensors which are totally different. But it's I don't want to elaborate on that in this round, because I would need some many hours, I think, to explain the details. So, for example, there are, if we have landing sites where these objects have landed, and we see that they are changing something. So maybe there are no plants growing on this spot for some years, or people are feeling have strange feelings if they are on this place, or sometimes if you go there, if you have a camera, for example, then the camera doesn't work. You go outside, it works. You go inside this place, it doesn't work. You can repeat this. I know such cases. It's credible. So there are some kind of whatever which is at this place where this object has landed, and this maybe can be detected, but it cannot be detected by conventional sensors, or only indirect. Of course, if your camera doesn't work, that's also some sort of detector, because it's changing some properties, for example, for some material properties. Maybe the crystal oscillator of your hardware has a different frequency or whatever, and then it doesn't work. But this is very unconventional stuff.
Yeah, we're talking about force fields.
Yeah.
And
So
and therefore, force fields we can only detect via non-directional approaches, non-directional sensing, and and all those detectors are short range.
I think that's also some people. I know some people who have some kind of sense for UFOs, so they know, oh, I have to look in this direction, and then they see it. So they are connected to it somehow, and we don't know how this is working.
Yeah, put this way. For example, Christian looking on his telescope, and he sees the stars far, far away. Actually, he detecting what was happening maybe million years ago, right?
Yeah. I've got a time delay, yes. I'm looking back to the past.
Big time delay. So what we talking about? You know, this is very, very tricky, very tricky subject.
That's also what I have on my fisheye cam. I see what happened 2 seconds ago.
Yes.
Okay. So let's round this discussion up, I'd say. I just wanted to bring it up because not going deep into new fields of where we need tons of time and budget. I didn't want, that was not my intention to go that route. My intention was only there is this MIT guy and he has a very simple setup and it costs I think $100 per item, and you take 2 and you have kind of a scope even with this. So someone could just test the hypothesis whether muons, Mickey Mouses, whatever you call it, are detectable from a UAP.
Don't blame on us. Don't blame on us because you started. Sorry.
I don't blame him. I don't blame him at all.
Yeah, good point. But okay, I would say, the theory behind it would say it's some kind of bogus stuff, but it's interesting enough to spend that little money about it, and we see where we are going with that.
Exactly.
And in the end, if we just wasted some time, then we had a good time. Okay, but if we can succeed by that, and something is coming out of it,
I mean,
Yeah.
it makes only sense when
Wonderful.
the PT set rig is developed, so that we can mount whatever on that rig and point it towards
Yeah.
an object. It's not of interest before, so it's not interesting to measure the environment or whatever, what have you, because as long as you don't know
some
where
kind
it is
of ambient field is a little bit too much to measure with it. A point source would be good.
Yeah, exactly. So as long as we can point a sensor towards it, it doesn't make sense to me. So let's come back to this discussion when we have a PT set rig, when someone actually is there and can pick that up, that idea.
Yeah, if we want to invest a big amount of money, we can set up hundreds of such detectors pointing in any direction, and then we can use it for detecting the interesting object. But this would be expensive.
But Wolfgang, you've got a telescope that you can mount such a device on. I've got one, and we can have a try and detect something from, let's say, the ISS. And this is a good way to start it. We can just mount it on the telescopes we have and point to
Hey, that's a good
a
point.
source.
Christian, a question. Do we know when the ISS is using its thrusters? Do we know that time?
Of course.
Is this
Yes.
locked? You okay?
Yes.
Do we know ahead
Yeah.
in time already when they use this thrusters?
We know ahead in time when they have to do it. I think it's about 2 weeks or up to 6 weeks in advance. Yeah.
It would be good because these are nuclear thrusters, aren't they?
So
you could expect some
no,
Mickey
I don't
Mouses.
think.
I think
No, I don't think. Yeah, normal gas flow.
Yeah.
Gas flow, sure. Because some satellites do have these nuclear thrusters.
Yeah, but not at that height.
Okay.
Because it's within the atmosphere, still in the atmosphere, and you don't want to expose the atmosphere to nuclear materials.
Yeah, probes will use ion thrust.
Yeah,
I've never heard of a satellite using.
But they are using it for power generation, but not for position.
A nuclear battery.
Nuclear battery, yeah.
Nuclear battery is the bird.
Christian,
what you mean is an ion thruster for maybe, but this is something different.
Yeah, you need a large power source, and you just throw charged particles through an accelerator out the back of the probe. I thought that was what Richard was talking about, because that's the only way you would create thrust with a nuclear power source at this point in the game.
I think
on the ISS you do not need that.
Okay.
I think we cannot detect anything from the ISS, only light and some radio waves, but nothing else.
Okay.
Yeah, but if we don't try, we won't never know. Maybe they were using some kind of
nuclear
special
toilet
technology, and they are producing it there. Yeah.
Time is finite.
Give it a try.
But that's called secret space program. What do you mean?
Okay, may I put a last question to the round? The question rose last weekend, and Jannik, maybe you can follow up on that. The question was that when whatever external source there is, if there are somehow costs applied. My question was, and it wasn't answered last week, so that's why I re-raise it. Can we, in some way or form, retrieve this data and store it on one of our servers so that all of our stations within our network can retrieve that data from our servers and not creating thousands of API calls from the source? And if
that's the weather map API that you are referring to, right?
Yeah, right.
So I haven't done any work on this today, so I have to say, I have to answer that at a later point, actually.
Okay. So when you got an answer, what I would be interested in is what is needed, what kind of server is needed, and how do we store this data and so forth.
Okay.
So in order
Yeah.
to prepare that infrastructure for it. Okay, any other topics? Someone wants to raise a new topic? We have 10 minutes left if you want. By the way, welcome Wayne, the Gandalf.
You wanted to talk about the issue which I found about the hood.
The hood.
Okay.
Yeah.
So
the dome of the PTZ.
Yes. So what I have, so I think there's not so much to discuss. So I have done an experiment with my Nikon P1000, which is pretty close to what is planned to use. So from pixel size and focal length.
Yeah.
And I put some plastic sheet in front of the lens. So this is, I don't know exactly what kind of plastic it is. I think it's polycarbonate maybe, but it's very clear. So if you look through this plastic, it's very very clear. So it's better than the normal glass. So if you look through it with the naked eye, you don't see any degradation of quality. But if you use it in front of the lens, you see that the contrast is slightly decreased. Yeah, but yeah, it's still okay, but it's not perfect. But if you distort it, so if you make a curve, a slight curve into this plastic, so like it would be in the hood, then you see that the picture is completely unusable. It's so blurred that you cannot see anything, and this is my concern. So if you are looking through a curved plastic, or I think it doesn't matter if it's plastic or glass, then this is degrading image quality, so that it's cannot be used.
So the only thing I'm familiar with, again, I work in healthcare, is the Stryker surgical lens. So surgeons who use face shields to keep when they're doing the bone saw and it sprays blood all over the room, because that happens, they've got, goggles, and then they have the face mask, and it goes to a little helmet. And the plastic will distort their vision, and of course they need perfect vision. So you can't really distinguish this material from a regular sheet of polycarbonate that's thin. Actually, I think I have one here at the house. But it's adjusted in such a way, the material is corrected in such a way that no matter how you wrap it around your head, because it's just a flimsy piece of plastic and they just screw it into the top and it's totally disposable. But there is some method they're using in producing it that it corrects for that distorted effect that comes when you bend plastic. You see the same things when you put on cheap sunglasses. I can't wear sunglasses because it annoys me, because there's always this little bit of distortion that I can pick up on the edge because of the curvature of that plastic. So there are corrections.
Of course, you can correct every distortion with a lens which is inverting it. Of course, yes, but I think this would be very very high effort. So I think it would be better to design the PTZ camera in a way that the camera is in a housing and the whole housing is moving, and you only have a small window, a flat window, which is fixed to the camera where you are looking through, and the complete housing of the camera is moving. So that's like a normal security camera.
The housing is moving.
But that is the point here. The created dome is moving around, and it has just a small, let's say, front glass cover that's fixed to it.
I see his point. But that small glass cover in the current design is curved. It's formed to meet the shape of it.
Two-directional form, actually. Yeah.
What if we were to?
Yeah, but this is just a design approach. It's not. We are not there yet.
Yeah, but
in the end, we're using just a flat glass cover in front of the lens, and that's all.
Yeah, but I think you are looking through the hood.
Yeah.
So the hood is so yeah, you are not looking through the same piece of material all the time.
Yes, you do.
You are
No. The hood is mounted to the rig, so when the rig turns, the hood turns.
The hood is just designed to be transparent, but it has not to be like that. The optics we can use whatever we like to do it, and if it's transparent for, let's say, because it looks better, then yeah, we can use it.
but the hood is, so maybe I misunderstand it, but the hood is closed.
Yeah.
And you are looking through the plastic
Yeah.
of the hood.
Yeah.
And so it must be curved.
Yeah, but what you propose
No,
is quite the same.
It's not decided yet.
Yeah, but it's the current status.
Because we are not there yet.
Yeah, but that's he was talking about the current status, and yes, he's right. But
Yeah.
Wolfgang, your solution is the same. No matter what you do, as long as you put something in front of your scope, you have that situation.
Yeah. Yeah, but
I see what he's saying though.
But then you have to. It's difficult. Maybe I switch to German for some sentences to it. I can say it better in German. So, was ich meine, das Fenster vor der Kamera ist ja nicht mit der Kamera verbunden, sondern man guckt ja durch.
Doch, ist sie.
Das bewegt sich da, also so wie, aber dann ist die Haube ja praktisch offen und hat so einen Schlitz wie eine Sternwartenkugel praktisch, wo sich
Ja, genau.
Ja, aber diese Sternwartenkuppel oben hat vorne ist geschlossen vorne.
Ja, aber dann gucke ich ja immer, dann muss sie ja gewölbt sein, weil wenn ich jetzt praktisch, dann gucke ich ja durch gewölbtes Material.
Richtig.
Immer. Genau, das war ja mein Punkt.
Aber wenn du die Kamera drehst, das ganze Rig, der PTZ, sich dreht sich natürlich auch dieser Hood.
Ja, in Azimuth-Richtung, aber ich meine jetzt in Elevationsrichtung.
In Elevation, ja, hast du recht. Bewegen wir
ist
uns.
es gewölbt, genau. Und das ist das, was ich simuliert habe. Ich habe es auch in Elevationsrichtung gewölbt und dann wird das Bild halt so, wie es da war, genau.
Ja.
Ja, aber das ist ja im Moment nur an der Stelle praktisch das ist praktisch ein Designvorschlag, würde ich es mal so nennen. Das ist ja noch nicht Weisheit letzter Schluss, sondern wie es nachher ausgeführt wird, wird das natürlich komplett anders aussehen.
Ja,
das wird wahrscheinlich dann mehr in einer Art Kugel oder sowas montiert sein und dass man praktisch so etwas wie eine Art Schmidt-Platte davor hat, weil du musst halt eben ein paar Sachen doch noch rausnehmen. Und es wird nachher die ausgeführte, produzierte Version wird auf keinen Fall so aussehen.
Okay.
Weil diesen Punkt, den habe ich eigentlich, als ich das erste Mal praktisch dieses Design gesehen habe, ja schon angeführt. Also das ist, wir haben das nur einfach erstmal so gelassen, weil warum sollen wir uns über das Design Gedanken machen, wenn wir erstmal die Technologie entwickeln?
First of all,
muss man im Hinterkopf. Ja.
Okay.
First of all, we switch back to English.
Go back to English.
For a second, I'd say there are a lot of cameras out there that uses domes, acrylic domes that are of such good production that you do not see a difference with and without the dome. Of course, yes, you have a decay in illumination. You certainly lose some photons by this, but they are so exact in production that there's no distortion, which is, from my point of view, the most important fact here.
Maybe they have a compensation in the lens for this distortion.
Why?
Because if
you have a distortion and you want to compensate, you do not have to have a lens. You can use a lens, which makes it just more complicated and more expensive. But you can also do it by software, if you really need to.
It's very
Can we
difficult.
use these plastic lenses? I mean covers
Yeah.
or whatever you call them in advantage, like a filters.
Not really, because you don't want to filter out. It is just a dusk and humidity cover, and if we reduce that to what is exactly usable, let's say high polished and maybe Lotus effect coated glass plate with the most transparency that we can get out, then I think that will be enough. And we can produce it like that. That only the lens is covered with it, and the dome that is used is made of normal plastic, let's say.
But
So it's
still, you
not
have to close the
only
dome.
no cover, no filters, no nothing, just
Yeah,
Yeah. So Christian,
it's just a cover for dust and humidity.
Yeah, but so like in an observatory.
Yes.
The cover, but then you have to you need some moving.
we do not close that cover. No. Sorry, to guys. So I have to break here in. This cover has to be there, and all the equipment has to be underneath that cover, because, as Christian said, there's moist, there's dust, there's all kind of bird poop, whatever. We do not want to have this inside. Okay, so the scope has to be behind some glassy material. And yes, I understand your concerns, but think of it. There are domes that you can buy from the shelf in any kind of size. They go up to a meter in diameter, and they are perfectly shaped without any distortion. And the thing is, if you put the spinning point of your scope in the center of that dome, and you turn around the dome within, turn around the scope within the dome, or even turn it with the dome, you always have the same curvature, because it's a ball, it's a sphere. This
I
dome.
know what you mean, but I'm not sure if so. It has to be tested. So because the normal security cameras, they have not so high magnification and resolution. So
yeah, the HUA cameras that people are using have 40 times magnification, which is about the same as we have. So
yeah, for the PTZ.
yeah,
And if that cover is very, very close to the aperture, it doesn't really matter, because
exactly.
then it is very, very unsharp and unfocused. So if we would put it, let's say, up to a meter distance, then yes, of course, you would see the reflections and the distortions.
Then you
but
would see
if it is close to it, let's say about 1 centimeter, then those distortions are with the magnification of let's say 40, we get out of the acuter optics, then I think it won't disturb our image, because we can refocus.
What you mean? You don't see any dirt or any objects because it's unfocused. Yes, but it's acting like some kind of lens if it's not flat.
It's distorting, absolutely. But this distortion can be compensated by software.
I'm not sure.
Maybe we do not have to.
It works. It's simple.
Maybe we do not have to, because if the distortion falls under the resolution limit, then it won't be any issue. We have to try that out, because and it depends on the curvature of the dome we choose. if the curvature radius is small and we can have some coating on it that reduces it to the maximum, we might not need any software solution for that.
But I think a dome of this size and in good quality, it's very expensive.
No,
I think it's.
we do not
I
use
think-
this
Not
dome.
really.
The dome was just an example for the
No.
same shape of the hood. The hood
Yeah, but
in
I-
front of the scope has the same shape of curvature and everything because I cut it out of a sphere. So
Yeah,
the
but
portion-
I think we should not have any hood at all. We should
Sorry,
have the
that's
camera in a. Huh?
That's- No, this station, what we designed for, has to be put autonomously somewhere
Yeah.
in the mountains. There's no
Yes.
one who goes there and opens a window. Now it's a clear sky and it's not raining. So now PT said, do your task. No, it's not working that way. This station
No.
has to run Yeah, excuse me.
Yes, yeah, and I know you're not understanding what I mean. The
Okay.
construction has to be different. The camera has to be in a closed housing with a flat window, and this whole housing should move. Then you don't need any hood.
But call it housing, call it hood. What's the difference?
No, it's imagine a normal security camera.
Yeah,
A normal security camera has a housing
yeah.
where it's inside, and this
Yeah.
housing is on a platform which is moving. Which is
I get your point. I know what you
yeah.
mean. Yeah, okay, I get your
Yeah.
point. It's a
Yeah.
kind of a tower where the
I wouldn't say
compartmentalized.
it's not important to discuss the look of it right now. Let's build it first, and then we think about the housing. I've got some ideas for the housing already, yes, but I don't think it's the time that we have to discuss it now.
I will show you in some weeks. Then I will have it.
Okay. Okay, great. Good stuff. Guys,
Yeah.
I'd say we have 2 hours. We close it down for the day. Or are there any topics you want to raise?
No.
Any other one? Okay.
Not at the moment.
I'll stop the recording now.